All right, let's go ahead. So like I said, today's a big review. We're going to just basically be doing a lot of practice problems. And the best thing that you can do is, I think, is ask questions if you have questions. Say an answer if you think you know the answer. Because then if you get it wrong, I'm going to know how to adjust and what I need to teach again. All right. So can I get a volunteer to start with number 1 for us?
Read.
Mm-hmm.
The diagram represents the dilation with the center at P. If the scale factor of the dilation is K, which statement about the diagram is true?
Cool. All right. So clearly this diagram has more than one dilation, right? We have at least 3 triangles if you look at it this way. We got QPR, we got QST, and then we got that big one, PUV. So think about it that way. There's 3 triangles. So I want you guys to read through those answer choices and start thinking about which one might be right. I'll give you about 30 seconds to a minute to do so, and then we'll try it together. All right, so let's talk about this. So it looks like they're comparing not necessarily the whole triangle, but they are talking about, we've got QR, ST, and UV. Okay, statement number 1, true or false? If K is greater than 1, then the image of ST could be QR. True or false?
I think false.
False. Okay, good. Because which one is bigger, ST or QR? ST is longer, right? So if K is greater than 1, what does that do to a figure if K is greater than 1?
Does it make it bigger?
It does. What's the mathematical word for that? Anyone remember?
It. I feel like I should know this.
Starts with an E.
Exponential growth. I'm joking.
No.
E and enlarge.
There we go. That's an enlargement, right? So that wouldn't make any sense because ST going to QR would be not an enlargement, but a reduction. So that is incorrect. Number 2, or letter B. If K is in between 0 and 1, then the image of QR could be UV.
No, because if it's in between 0 and 1, it will be a decimal, and decimals cause it to shrink.
Cause it to shrink. You got it. So that is also fake news, incorrect. C, if K is greater than 1, then the image of ST could be UV.
I think that's true.
Yeah, right. Now it doesn't
I
say how
agree.
much K is. It doesn't say the actual value of K. But yeah, this would, like we said, this would be an enlargement. So ST could become UV by enlarging. So yes, that is true. And then now let's just check the last one. If K is equal to 2, then the image of QR is itself. Now, what would K have to equal? That would be if K equals 1, not 2. So that is that. Questions on number 1 is kind of just the basics here.
Doesn't it look like PST is like half of PUV?
PST half of PUV. It does. We can check. How can we check?
Don't tell me about these distance formula.
We would. Now, I'm not telling you that you have to right now, but why would you need the distance formula as opposed to being able to just count it?
Because it's like not exactly one cube. Like some of them are cut off and not exactly full.
Right. So you can't count it because it's not vertical and it's not horizontal. All of those lines on there are slanted in some way, so you can't count those cubes because they you're not able to do so. So yeah, you would have to use the distance formula, and if you use the distance formula, you can figure out what the scale factor is. All right, so good question. Any other questions on this? Cool. All right. Here we go. Triangle ABC has been dilated from center D. If the length of segment BC is X, which is the length of segment ST? So BC, they're calling this X, right? And okay, so now they're asking us what is ST? So in other words, what are they trying to get us to calculate?
The scale factor?
Yeah, the scale factor. Because remember, the scale factor is what you multiply the pre-image by in order to get your image. So if ABC is my pre-image, I'm going to need to calculate that by a number in order to get RST. So our answer choices are basically giving us the options for what the scale factor is going to be. Well, in order to do that, Jalen, what am I going to have to do?
Look at it. Well, AB is 3.
Oh,
But
okay,
you need to find scale factor.
so in this case, I can count, and that's very lucky. You can't always do that. So here we got 3 for AB.
If you figure out one side, figure out the other.
You got it. So what's this SR?
That's 6.
6. So what's my scale factor?
It's Perla's time to shine.
Good. The scale factor is 2, exactly. So if BC is X, then ST is just going to be 2 times X, so 2X. Making A our answer. As a reminder, scale factor, if they tell you that one is the pre-image and the other one is the image, or even the way they say it here, triangle ABC has been dilated, right? So whichever one was dilated is the pre-image. So therefore, when you do scale factor, remember that it's going to be image over pre-image. Or if it helps you remember, new over old. So that's how we end up with the number 2. Any questions on that? If it was the other way, let's say RST was the pre-image and it shrunk, what would be the scale factor?
1. Dang it.
1/2. 1/2. All right. All right, so this question I really like because if you guys remember from the EOC for algebra, this is kind of like the format that they use, right? So it's very similar to what you'll see on an EOC. So let's go ahead and take a look. Can I have a volunteer to read? Who's reading?
Casper. I'm joking. Line segment AB is shown on the coordinate grid. Line segment AB is dilated by a scale factor of 2 with the center of dilation at the origin, resulting in line segment A and B prime. Use the connect line tool to draw segment A prime and B prime.
Perfect. All right. So very important information here that where's the center of dilation?
The origin.
The origin, right? Now, this is something I want to be very clear about, and we can write this down, okay? When the center of dilation is the origin, only when it's the origin. If it's any other point, this is not going to be true. This only works if the center of dilation is the origin and the scale factor is k, whatever k is, then xy becomes kx, ky. So go ahead and write that down. I just wanted to be very, very clear about this because sometimes the center of dilation is the origin, and then sometimes the center of dilation is another point somewhere else. So when it's the origin, it's actually much, much easier to figure out where the new line segment is going to be. So go ahead and write this down, take another 10 seconds, and then we'll do the problem. All right. So since this is the case for us, right? The center is at the origin, then my scale factor is 2. So my coordinate points, simply, we're just going to multiply them by 2.
That's what I'm about to say.
Yeah. So it's very, very simple. So let's just label them real quick. I've got 3 comma 2 and 0 comma negative 3. So go ahead and apply that dilation to A and B, and then let's see, what does A equal? A prime? And what's B prime going to be?
You put that one wrong.
Which one?
X
What do you mean?
on A.
On A. 0 comma negative 3?
It's negative 3 comma 0.
Oh, you're right. Sorry. Thank you. There you go. Okay, so what would A prime be?
Negative 6 comma 0.
Negative 6 comma 0. And then B prime?
6 comma 4.
6 comma 4. Exactly. And so now I can just go ahead and put those new points down. And then, on this, whatever they use on the EOC, I think you first add each point and then you connect them using the connect button. So 6 comma 4 and negative 6 comma 0. There it is. Okay, so, and then just things to remember is that, remember what I said a little bit ago, but the center of dilation is the point where all of these are going to converge. So if I connect B and B prime and I connect A with A prime, they're always going to meet up at the center of dilation. And you can always check for that. So like if you get your answer and then let me make an example. Let's say you do it and you think it's going to be like this. You make a mistake. Let's say you make the same mistake I made and I switched my X and my Y and I made this 0 comma negative 6. Okay. If I did that, I would end up with something here. Where would that be? 6 comma 4 right here. So let's say I did this and now I'm looking at my result. And first of all, what looks wrong about this? They're not parallel, right? So that's one big thing, is that they should be parallel because that's one of our rules about dilations. So already I'm like, okay, something's a little funky. And then if I actually connected those dots, A with A prime and B with B prime, they don't converge at the right place. Where should they meet up? They should meet up at 0, 0. They should meet up at the origin, but clearly I made some mistake. I did something wrong because that does not. So that's always something that you can check for. You can just make sure that you did things correctly by making sure that the center of dilation is where you intended it to be.
You flipped A.
I flipped A, yeah. Okay. All right. Questions on this one? Cool. Okay, lots of words. You know what that means. Who would like to read?
I'll read. Time will break. A line segment is dilated by a scale factor of 2 centered at a point not on the line segment. Which statement regarding the relationship between the given line segment and its image is true?
Perfect. So I don't see a picture. I'm going to just quick draw one. You know, it's always good to visualize. So it says there's a line segment. It's dilated by a scale factor of 2, centered at a point not on the line segment. So that means I have a line. I'll make this one short. It gets longer, 2 times longer, and the center of dilation is not on the line itself, so it's somewhere off to the side. So I'm just going to put it anywhere, put it right here. And I already know that the way this works is we're going to just connect these dots until I'm twice as long. So somewhere over here. Now I'm obviously just estimating it. This is not perfect, but it's just a way for me to visualize. Okay. And then it says, okay, which of these is true? So now let's go ahead and read them, and then we can refer to our picture and to our knowledge and see if it's true or false. A, the line segments are perpendicular and the image is 1/2 of the length of the given line segment. True or false? Yeah, definitely false. Are these perpendicular lines?
No, they're
No.
parallel.
Yeah, they're parallel. So take a look at that. We can eliminate A as well as B. C, the line segments are parallel. Okay, good. And the image is twice the length of the given line segment. True or false? Sounds about right, right? Yeah, twice the length. Yeah, AB is 2 times as long as, or AB prime is 2 times as long as AB. So that's true. And this one's a very basic, just, do you know what a dilation is? Do you know what it's supposed to look like? Type of question. So it's not really that tricky. It might look like it's difficult because it's a lot of words, but it's just asking to make sure that you know that, first of all, they will be parallel. Second of all, the image will be twice as big as the pre-image due to the scale factor. Okay, not so bad, right? Moving right along. Okay, now we get a little bit more tricky. I see numbers. Who would like to read this one?
In the coordinate plane, line P has slope 8 and y-intercept 0, 5. Line R is the result of dilating line P by a factor of 3 with center 0, 3. What is the slope and y-intercept of line R?
Awesome, awesome. Okay, couple of different things. So I'm going to highlight a couple of things. Line P has a slope of 8. And it's been dilated, right? What did we just talk about in the previous slide? What happens to the slope of a line that was dilated? What's that relationship? It's going to be the same, right? Same slope. Why is it the same slope, Perla? 'Cause 'Perla? 'Cause 'Perla' 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 ' Good. They're going to have the same slope because we know they're going to be parallel, which is something that right off the bat, I didn't have to do any work at all, and I can eliminate 2 answer choices. Okay. Now, here's the part that's a little bit trickier. Line R, or it's asking you what is the y-intercept of line R, okay? So I'm gonna read it one more time. In the coordinate plane, line P has a slope of 8 and a y-intercept of 0, 5. Line R is the result of dilating line P by a factor of 3 with center 0, 3. So they're telling us where the center of dilation is. Okay. So start thinking based on that information. Think of what you think might be the answer. I see that Perla has her guess, but I'm not going to say whether or not that's true yet. Think about what you think is the answer, and then I'll draw it out and we'll see if your intuition was correct. Okay. Now, let's actually think about this logically. I'm going to just kind of draw my y-intercept, my y-axis. Not going to draw the x-axis because it doesn't really matter where that is because we're not really talking about it. But here's one line, call this line P. And we know that it's passing through the y-intercept at 0, 5, right? Actually, I'm going to move P down a little bit just so I have more space. Okay. So they're telling us that, okay, the y-intercept is at 0, 5. Then it's being dilated with the center of dilation at 0, 3. So where is that, above or below my line? It's below 0, 3. Okay. And we know that the scale factor, highlight that in orange, scale factor is 3. So remember what scale factor means. The scale factor is not just how much bigger the shape is going to become, but also how much farther away from the center it is. So let me actually back up. Let me show an example. There was a good one here. Okay. This is a very good picture because it helps you to visualize it. So this was 3 and this was 6, right? So yes, the shape is twice as big. That is good. But also what's happening is that the distance from the center is also twice as long. So CD, whatever that is, I'll just call it Y. If you go all the way from D to T, that's going to be 2 times Y, because the distance from the center also has that same scale factor, okay? So based on that, here's my problem here. How long is this distance from the center to the y-intercept? 2 units. So my new line has to be how many units from the center? If the scale factor is 3, the scale factor is 3, so it has to be multiplied by 3. So if line P is 2 units away, how far does line R have to be? Six units, exactly. So call this, let's say that's 4 units. That's where line R needs to be. Okay, so there's my new line. Line R, it's parallel. And because of the scale factor, where does that end up? Where's the y-intercept? Zero comma 9. So Perla was correct. C is our answer. Good job. Questions on this one? This one was definitely a lot trickier. Okay. All right. Moving right along. I'll read this one. Square ABCD is shown on the XY coordinate plane. The square will be dilated with the center at O, so at the origin, by a scale factor of 2 to create a square ABCD prime. Which statements are true? Select all that apply. Okay, so first things first, I want you guys to take a look at them. I want you to try it on your own. I don't want to draw it out quite yet, but I want you guys to start thinking about what you think might be the answers. So take a look at them, take about a minute. Make your selections in your head. You can tell me what you think it might be. I don't know. Do you want me to do a poll? I should do a poll. Yeah, let's do a poll. Okay. Don't click F. Okay. Couple of seconds remaining. Just right now we're just kind of guessing. It's not going to be your final answer maybe, but just what you think it might be based on what you know. All right, 5, 4, 3, 2, 1. Okay. So good amount of votes for A. Few people chose C as well as D. And then the rest of the answer choices we were maybe not so popular. Let's take a look.
People chose F.
Someone chose F. Of course someone chose F.
It's
right.
multiple choice, so it really doesn't matter.
Yeah, it does though. It does, because if it's select all that apply, you have to get only the right answers. So I'm going to begin by just extending these lines from the center and then just out, crossing each of those points. Ooh, that was crooked. Okay. So first things first, I know that the scale factor is 2, so I know that my image is going to be bigger or smaller.
Scale factor 2 bigger.
Bigger, right? Now the center of dilation is the origin. So what little trick can I quickly do?
D and E.
D and E? I'm not
Wait a
asking,
minute.
well, I'm not asking
I
about
was
the,
not eliminating questions. I thought I heard something. I heard something wrong. My bad.
oh, no worries, no worries. No, just what Perla just said. So I can basically take each coordinate point, multiply it by 2, and figure out where I need to go. So no distance formula necessary. We don't have to do a whole lot of math. So A is 1, 3. So what will A prime be?
6,2.
Ah, you flipped it
2,
this time.
Wow.
2,6. 2,6 right here. B is 3,4. So what will that become? 6,8. Cool. Oh, my line was so crooked. I didn't even come close. I'm gonna have to fix that. Okay, C. There we go. C is 4,2, so that becomes good, 8,4. That was better. And then D used to be
4,2.
good, so it becomes 4,2. So there it is. So there's my image. I'll connect the dots, and then we can see if your guesses were correct. All right. So let's go down the line. True or false? BC is parallel to BC prime.
True.
True. Yeah. And you should have known that without drawing it, right? Because the image will always be parallel to the pre-image. How about B? AC is congruent to AC prime. No, false. It's twice as long. Twice as long. C, AD, so let me connect that. AD is perpendicular to CD prime. Perpendicular. Uh-oh. True or false? This one's a little bit trickier. Now, something that might be tricky is that AD doesn't actually connect with DC prime, right? They don't connect. However, what does perpendicular mean? What's the definition of perpendicular?
90 degrees.
90 degrees, right? So it's a little bit tricky. I think this might be one of those trick questions type of things. But because even though they don't touch, they're asking not about the line segment themselves, but the length, the measurement of them. So you can kind of think about them wherever they are. If they came together, would they make a 90-degree angle? If they did touch. They would, right? So in that sense, the C would be true. Even though they don't touch, what's true about their the slopes. The slopes would be,
Well, the square has 2 slopes. It has 1/2 and 2.
1/2 and -2. Negative
That.
2. So they're opposite reciprocals, which makes them perpendicular. So this one's true. Little tricky. If you picked no, you can argue that you're correct, and I'll give you that point. All right, D. Point D has the same coordinates as point C, or D prime has the same coordinates as point C.
True.
Yeah, true. And then finally, point C prime lies on the same line containing points O and C.
False.
This is a little tricky. So the line containing O and C will be this line right here. Does C prime lie on that same line? Yeah. It's because point O is the point of dilation. So of course, if you extend that line, it has to touch, by definition, it has to touch both C and C prime, since it's a straight line. So the only one that was absolutely wrong was B, and then you could argue that C is also wrong, but since it's not a test, there's no need to do that. Questions on this one? This one was a very good question. All right. Awesome. Next one. Here we go. This is another sort of EOC type of format. Can I get a volunteer to read this one for us?
Huh?
Go ahead.
Read.
All right, the equation of a line is 6x minus y is equal to 5. A dilation center at the origin with the scale factor of 6 is applied to this line. Wait, read the part A, part B part, or no?
Just part A.
What is the slope of the line after the dilation?
Okay, yes, I did unplug my earbuds because they were bothering me, so I took them out. So you might hear like my computer sounds in the background. So first things first, this is a little bit different because now I'm kind of merging together algebra with geometry, which I know you guys love, right? It's like your favorite part of the day.
No.
Absolutely not.
I have, well, it always comes back. I have the equation of a line. What form is this written in?
Standard.
It's in standard form. And then they're asking me about slope. But what do I need to do to this equation in order to know the slope of it? We're going to convert it to slope intercept, exactly. So 6x minus 3y equals 5. Let's turn that into slope intercept so that we can know what the slope is. So first things first, what do I do? Subtract 6x, I'm left with negative 3y equals negative 6x plus 5. Now what? Divide by negative 3, leaving me with y equals, what's negative 6 divided by negative 3? It's positive 2. So 2x. And then 5 divided by negative 3? Is that going to be a nice number or no? No, so we just leave it as a fraction. 5 over 3. So here's the original equation. Remember that we started with this. Then it gets dilated with a scale factor of 6. Okay, so now let's put it all together. What is the slope of the line after the dilation? Good, Perla. 2. Remember, the slope, does that change when you dilate a figure? Will the slope change? No. So if the slope is 2 to begin with, it's going to be 2 at the end as well. So slope is 2. Part B, what is the value of the y-intercept of the line after the dilation? So the y-intercept of the original is negative 5 over 3. But that's a coordinate point. That's 0, comma, negative 5 over 3. And where's the center of dilation? Origin. It's at the origin. And what's the trick we can use only when it's centered at the origin? Exactly, Perla. So x comma y becomes 6 times x comma 6 times y. So we're just multiplying. 0 times 6 is still 0. But what about negative 5 over 3 times 6? Negative 10. Negative 10 is our answer. That is the y-intercept. And how do I know that that is a y-intercept and not like just a regular point somewhere else? How do I know that's the y-intercept? Good, because it's 0 comma negative 10. So I know that that is on the y-axis. So I know that that is my y-intercept. So this one was definitely a little more challenging. Can I have, if you have any questions, any confusions about how we got those numbers, let me know in the chat. Okay, good. Oh, I got one question. How did I get -5/3? Would anyone like to answer that? How did we get -5/3? When we divided. So when we were turning it into slope-intercept form, we had to divide 5 divided by -3. Well, a negative or a positive divided by a negative ends up negative. So instead of calling it +5/3, I just made the whole fraction negative, if that makes sense. So you can't divide and get a nice number, so I just left it as that. I left it as -5/3. That's it. All right, cool. Here's another. Two triangles are shown. Which is a true statement about the two triangles? Take a look. This is now, we're kind of switching gears. We're talking about triangle similarity theorems. So take a look, take a minute. In fact, let me put up a poll and make your selection. Go ahead. Okay, make an answer selection in 10, 9, 8, 7, 6, 5, 4, 3. Ooh, two answer choices are tied. And time. Okay. So they were tied up until the last second, but in the end, answer choice D was the winner. Thanks to Jalen and Perla. And in fact, that is true. So let's talk about it. First of all, how do I know that they are similar? How do I know A is out?
Because they both have a 90-degree angle.
They both have a 90-degree angle. Is that enough though?
No.
What else do I know? So I'm seeing that they have two congruent angles. Which ones are congruent? Because 37 is not congruent to 53.
Wait, that thing that I just put is gonna count. But it's kind of like flipped and like reflected, but you just have to look at it the right way. So let's say B is D. So EDF is congruent to CBA, like that. That's how you're supposed to look at it.
So A corresponds with F and B corresponds with D and C corresponds with E. And how do you know for sure that C and E, for example, are congruent? Like, how do I know that C is 53 degrees as well?
Well, what I did was that I like first found the like missing angle for one of them and see if they they both have the three angles. So then I just matched them. Since the 90-degree angle, we know which one it is. And since 37 is A and 53 is E, then I just matched them like that and like filled in the missing spots.
Good. And we know we can fill in those values because they have to add up to 180, right? So 90 plus 37 gave me, what does that give you? 127. And then 180 minus 127 give me 53. So I knew that this was 53, and then this is 37, if you do the same math. So once you fill in that missing angle, you know that they're definitely similar. The angles are congruent. So
You
then,
know how I did it?
how'd you do it?
I just added 37, 53. Well, I didn't find the missing. I just added those two, and I got 90.
Yeah, but you can't use that if you do it that way. Actually, no, that does make sense. Yeah. What you
Then I
did
found the missing angle.
works too. Yeah. Okay. So now I only know a few things about these triangles. I only know the angles. Do I have a single side length measurement in there anywhere?
No.
No, right? So because of that, I can't use SAS because SAS requires you to have two side measurements that you know about. We don't know about them. We don't know how long they are, so we can't use it. So that one's out. And then the final thing was just to make sure that the similarity statement matches up correctly. So kind of like what Perla was saying before, since A matches with F, B matches with D, and C matches with E, then that means A, B, C is similar to F, D, E. So that was just a matter of getting the letters in the right order. Okay, so any questions remaining on this problem? Awesome. All right. Series of transformations, sequences of transformation. So more than one transformation is happening to go from one to the next. Which sequence of transformations can be used to show that FGH is similar to FGH prime, double prime? So start thinking about it. Similar idea. I want you guys to try it on your own. Give me an answer, and then that way we can talk about it. So I put up the poll. This one will take a little bit longer, so take your time. But when you're ready, you can put up an answer. Okay, I'll give you guys about 30 more seconds. So if you don't have an answer yet, start wrapping it up. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So 5 people voted, few of you did not. So that already tells me that we're having trouble with it. But the winning answer was answer choice A. So let's take a look. First things first, before you look at the answer choices, I always want you guys to think about, remember, which one is the pre-image, which one is the image, is it getting bigger, is it getting smaller, what is happening? So can anyone tell me, without even looking or thinking about the answer choices, just describe to me what happens?
The triangle became bigger afterwards.
It became larger.
It probably got rotated and reflected. Or no, probably a rotation or reflection.
Rotation, maybe a reflection. Okay. So we know that for sure it got bigger, and then there was something else that seems like it was rotated, maybe reflected, right? So in other words, it changed the orientation. So whatever happened, it turned in some way or another. So that already is going to help you eliminate a lot of answer choices, because if it's getting larger, scale factor has to be what? Greater than 1 or between 0 and 1?
Greater.
Greater than 1. Scale factor should be greater than 1. So which answer choices can I eliminate right off the bat?
CD.
C and D. Right, because they're telling me that the scale factor is 1/2, but I know it's got to be greater than 1. And then from there, now we got to think about what exactly is happening, what type of other transformation. Is it a rotation or is it a reflection? So let's think about it. So we start off over here, and it's a little bit tricky, right? Because are we doing this sort of thing, or is it flipping over the line y equals x? And to be completely honest, this is the type of question where I personally can't really see it that well in my head. So I might want to go ahead and do the math, because doing the math, that's never going to lie. If you're a little bit tricked out by your eyes and you're not exactly sure, then doing the math will give you the final correct answer. So I'm going to do that. I'm going to go ahead and do that, and then we'll know for sure. I'm just going to take a look at point G, and I'm going to use point G as my guiding point. That's the one I'm going to kind of keep track of. Where does G begin? Where is it located?
Coordinate point? Oh, never mind.
Oh, there it is. 3, -3. So then I know it gets dilated, right? So if it's dilated about the origin with a scale factor of 2, what will be the new coordinate point for G prime after the dilation? Scale factor of 2. Right, 6, -6. 6, -6. So I'm going to go there, and I'm going to mark it down. Here's G prime. Okay, and then I have two options. There was either a rotation of 180, or there was a reflection over y equals x. So let's take a look at, where does G prime actually end up? Look at G prime. Where's G double prime? Sorry. Tell me the coordinate point, because it's already there, so we can just look at it. -6, 6. Okay, so that's where it ended up. Now let's think about what type of transformation, what happened here? We went from, we had x comma y, and it became, they just switched. They switched places. They traded places. It became y comma x. What type of transformation does that?
Rotation. Wait.
It's actually not rotating.
Reflection.
That one is the rule for the reflection over y equals x. And that, if you memorize those rules and you noticed that, you would have known right away that it's actually answer choice B, not answer choice A. But this was a very tricky one because it's so similar. Those two types of transformations, they look very similar sometimes. But the other thing I want you guys, yeah, nobody picked this one. Everybody got it wrong.
Rip.
The other thing I want you to realize is that if this had been a rotation, if it had gone like just rotated, would the G end up on top like it is here, or would it have been on the bottom? It would be on the bottom, right? Think about it. Just like make a triangle with your fingers like this and visualize where G is. If you rotate it, it's on the bottom, right? When you rotate it to here, it's on the bottom. So very important to sort of, sometimes it's hard to visualize things, but doing the math will tell you for sure what the answer was. Would anyone like me to explain any part of that one more time? Because that I understand this one's a little bit more tricky than all the other ones we've done. Okay. All right. Moving right along. Now, the other thing though is all the answers I saw that people picked, it was A, C, and D. So those of you who picked C or D, just be aware that at the end of the day, those were the ones we were able to get rid of right away. So if you got rid of C and D, your chances of picking the right answer would have been a lot higher. Even if you didn't notice that it was a reflection, you would have noticed, you would have had a better chance of getting it right. Okay. Here's another one, kind of similar, but also maybe a little bit easier. Triangle ABC is defined in the coordinate plane by the points. A is 1, 1, B is 3, 4, and C is 4, 2 as shown. Under which transformations will the image of triangle ABC be similar to the pre-image? So which of those is going to give us a similar figure? Same idea, I'll put up a poll. Give me 1 second. Okay, go ahead and make your choices.
Wait, miss, if an option makes it the things congruent, will that be wrong?
I'm not going to give away that answer.
Can similar can mean congruent? No, never mind. That's wrong.
All right, 30 more seconds. Those of you who have not answered yet, go ahead and do so. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, this one was interesting. Here's the results. So we're kind of everywhere. So let's clear a couple of things up. I'm glad we're doing this problem. Let me be very, very clear. If something is congruent, is it also similar?
No.
So what's the definition of similarity? Similar figures have to have the same
Angles and proportional sides.
same angles and then proportional sides. Proportional just means that whatever the new figure over the old figure has to be equal no matter which two sides you choose.
Oh my god.
But if they're the same, if they are congruent, what is the scale factor going to be?
1.
1. That is still falling under the category of similar. So congruent figures are similar. However, it doesn't always go the other way. Okay? So just because something is similar doesn't mean it's congruent, but the other way is always true. Congruent figures are similar to each other by definition. So that already is going to change some answers, I'm sure. Now let's go through and read this type of transformation and let's just determine what is happening. So in answer choice A, what type of transformation is that? Is that something we know about? Just what type of transformation is it? So if I'm turning the x and the y both negatives, it's 180 degrees? Yeah, and you can kind of look. A prime would be here, 3 comma 4 would become -3, -4, and then C prime would become -4, -2. So there's my image. It's a rotation, 180 degrees. Cool. That leads to congruent figures. But like I said, congruent figures are also similar figures. So A is correct. Okay, questions on A? Now, what about B? What's happening in B? Good. In B, they're kind of doing like a 2-in-1 type of thing. They are translating the X and then dilating the Y. So what do you guys think? If you're only dilating the Y and not the X, are they going to end up being similar? Will that end up similar? No.
No.
In fact, let me just show. So for A, 1 comma 1 is going to become 3 comma 2. There's A prime. 3 comma 4 will become 5 comma 8. So it's like somewhere way up here. And then 4 comma 2 is going to be 6 comma 4. So it's like here. So here's my new kind of roughly drawn triangle. And it's not going to be similar at all. In fact, like it's just going to be a little bit funky. It's not going to end up being correct. So in order to be similar, the x and the y have to follow the same dilation. Both of them have to. Otherwise, you're only dilating part of it, and it's not going to line up correctly. So B is out. How about C? What's going on here?
It's shrinking.
It's shrinking. This is just a dilation. What's the scale factor?
Of 1/2.
K is 1/2. So here, the x and the y, they are both being dilated by the same amount. It's consistent. That will be similar. Okay, and then next one, what type of transformation is happening there?
A translation.
Good.
Yeah.
Translation. It's just moving. It's moving, it's staying congruent, but we already know congruent figures are similar. D is in. And then what about E?
Oh, stop ASMR.
Oh, I didn't realize it was on.
What's going on with E though?
They're both being enlarged, but at different scale factors.
Different scale factors. So this is a dilation with different scale factors. It's not consistent, and so therefore it will not be congruent or similar. So there you go. So that kind of cleared up a couple of things that clearly were not clicking correctly. So I'm glad that we did that, okay? First of all, rotations, reflections, translations, and dilations will all give you similar figures. And in order to be similar, the dilation must happen to the x and the y consistently. So, questions on that? All right. Here's another. I told y'all we had a lot going on today. I can't even give you the poll because this has too many answer choices. It goes all the way to G. So instead of polling, just send me your answers in the chat privately. Read it to yourself, do it on your own, and then we can discuss. In fact, I'll read it out loud while you guys start thinking. Triangle ABC is dilated with a scale factor of 1/2 and center P onto triangle DEF. Which statement must be true? Select all that apply. Okay, keep sending me your answers in the chat if you haven't done so yet. We'll start wrapping it up. Okay, so let's start thinking about it. AB parallel to DE, true or false? Is AB parallel to DE?
Yes.
Yes, definitely, yeah. DE is the image of AB, and we know that they will maintain parallel relationships. Okay. Angle A is equal to angle F. True or false? Angle A congruent to angle F.
No.
False. Definitely false. A is congruent to what though? Not F.
D.
D. Yeah. C. Angle B is congruent to angle E. True. Good. D. The length of segment AC is twice the length of segment DF. True or false? Good, Janelle's yeah, that is true. E. The length of segment EF is twice the length of segment BE. BC. EF is twice the length of BC.
I think it's false.
False, because this one's going the other way. EF is half the length of BC. If they had said it backwards, then it would be true, but this is false. All right, F, the distance from P to D is equal to the distance from P to A. The distance from P to D is equal to the distance from P to A. Definitely false. But how about this one? The distance from P to D is twice the distance from P to E. True or false? False. False was false. If this had said A, then that would be true. It would be true if it said A. But it didn't say A, it said E. So make sure you read that one carefully. So A, C, and D were the only true answers in this question. Final questions on this? Okay. Now it is 2:17, so this is basically the end, but let's do this one. It's super quick. Super quick. ABC is similar to DEF. What is the value of X? Can anybody very quickly give me a proportion that I can set up?
Like, wait. Oh, let's do big or small. 27 over 9 is equal to ABDE 21 over 7.
Which is, you're right, but I'm looking for X. So
X over 5.
good. And then we do the math, cross multiply and divide. So 5 times 27. $135 equals 9x. Divide both sides by 9. What do I get?
15.
15. X equals 15. All right, guys, good job today. We didn't get to, there were just 4 that we did not get to. So what I think I'll do is I'll just make those the bell ringers for the rest of the week. So I will see you all tomorrow. Have a nice afternoon. Bye, everybody.
Bye.
Bye-bye.